Hey guys, Chanky here. First off, I'd like to thank everyone for the amazing support over the past few weeks. I can't express how much it meant to me. So anyways, today I have a 100% efficient motor design that doesn't use screws. This design produces 15 motors per minute. I chose this output because turbo motors need 7.5 motors per minute, and since 15 is a multiple of 7.5, it makes it easier to start off the production for that in the future. The requirements are 150 iron, 150 coal, and 210 copper ore per minute. The alternate recipes include the solid steel ingot and the steel rotor recipe. Let's get started. The factory takes a 5x7 space. You'll see that I've color-coded and divided the space. The yellow space is where we'll build the smelter towers for iron and copper. The iron tower will be adjacent to the blue space, which is the space for the steel ingots and steel pipes, whereas the copper smelter tower will be adjacent to the green space, where we'll build the wires. The white space is for connecting conveyor belts between the towers. I've already made a video on the construction of smelter towers, so just use that. Make sure to build them with the output coming into each other. I'm not going to show the construction because I want to save time. These are the two smelter towers in question. The one on the right is the copper tower, and on the one on the left is the iron tower. Before we move on, there are a couple of variations that you need to see. So down here, as you can see, we have 3 conveyor belts stacked on top of each other. The one on the bottom is the copper belt, the one on the middle is the coal belt, and the one on the top is the iron belt. The copper belt comes through here and goes into the back of the smelter tower through here. The middle one travels here, it comes to the middle, and right on the white line I've made a double wall conveyor. The iron line then comes to the back of the iron tower and enters through the left socket of the double wall conveyor, where it joins a splitter. Because of how the iron ore line obstructs the side of the iron tower here, we had to make a small change in design here, which I'm going to show you right now. Normally, the output module of a floor would look like this, where we have a merger combining the outputs of the upper floor with that of the current floor and sending it down. In our case, on the bottom floor, we have 2 mergers. The merger on the left brings in the iron ingots from the upper floors and sends it to the merger on the right, which combines it with the ingots of that smelter and outputs it. Now the output of the copper tower comes through here. Now that you have both the iron and the copper towers built, we're going to build the foundries adjacent to the iron tower. And we're going to come back here, and this blue 3x3 is where we're going to be building the foundries. So to start building the foundries, what we're going to do is we're going to take a double wall conveyor and we're going to build 2 rows on this side, and then we're going to take the single windows and then place 2 rows of that and a single row of double wall conveyors, and then we're going to repeat this on the opposite side. And then what we're going to do is we're going to take the single windows and place 1 single row on that side. Now this is how we're going to place our foundries. We're going to place 4 foundries, 1 on each location like this. Now the one on the top right is going to be underclocked to 75%. So that one is going to be taking 30 ingots per minute and 30 coal ores per minute. So to start things off, let's first bring in our ingots into the load balancing. So first we're going to take a splitter and line it up with the second socket of the first double wall conveyor, and we're going to place it in the middle foundation like that. Then we're going to take another splitter, and then right beside it we're going to place the splitter like this. Now take a merger, and in line with the first splitter we're going to place one with the output facing this way. I'm going to keep one like that, and then one more splitter right there. Now we're going to take a Mark III conveyor belt, connect it up with the first splitter, and then we're going to use a Mark I conveyor to connect these 2 splitters up. And then we're going to use a Mark II to connect the splitter and the merger up. And then just use another Mark II here. Alright, so after that, what we're going to do is we're going to take a Mark I and connect it from this splitter to that socket. And now we're going to connect this splitter with the merger like this. And now we're just going to split from 3 ways from this merger to the different locations in our first floor. So we're going to use Mark III. No, actually no, we only need a Mark II here. So first off, let's keep one into that one over there. So just do that. The second one over here, and the final one right here. There we go. Now we're going to place the foundries, and to do that we're going to just keep it in line with the first double wall conveyor like this. Make sure to get as close as possible. We're going to keep one single space and then place the next one, and then repeat this on the opposite side. Alright, so then make sure to underclock the foundry on the top right. So it's going to be producing 45 per minute, and it will only need 30. It won't show here because it'll only update this once a single cycle is completed. It's a good practice to do the power as you go up, otherwise once you start putting up all the walls, it's going to be difficult to move through and keep the power line. So I recommend putting the power lines as you go right now. Now we're going to cover this up. Now that you have that built, let's just connect all of this up with our lifts. Make sure to go inside and connect that up with the foundries. Now we're going to do the load balancing for the coal, and to do that we first need to bring the coal to the top floor. And to do that, we're going to come here where we had our coal coming in, and then we're going to build a Mark III belt, and we're going to place it in the middle of the foundation like this. And then we're going to bring this all the way to the end of the second foundation and keep it right in the junction of the two foundations. And from this side, we're going to take a lift and lift it up and keep it in line with the double wall conveyor. And now just connect all of this up. So the load balancing here is exactly the same as before. The only difference is the cluster is shifted one splitter space down, and the sockets to which the outputs are connected are different. And then just connect everything up. Now we're going to use mergers to combine all the outputs. I'm not going to commentate here, the video itself should be self-explanatory. Mark I conveyor belt here, a Mark II conveyor belt on the other side, and then another Mark I between those two splitters. And then from here to the sockets, it's going to be two Mark I conveyor belts. More Mark I belts from that splitter. Use a Mark III lift to get the ingots from the constructors to the load balancing unit. Now this load balance is a bit different from the rest. The 15 in red is the required rate of steel ingots for the constructor, as we will be underclocking that constructor to 50%. At the first splitter, the incoming 105 would be split into 52.5 for each belt. But because the required rate is only 15, this will cause the belt to back up. Once it has fully backed up to the splitter, we want the excess to move to the other belt without traveling down to the previous floors. To make sure this happens, it is very important that the belt going to the next splitter is a Mark II, so that it can take the sum total of 90 ingots per minute. If they are both Mark Is, then the backlog will travel down to the bottom floors and seize the foundries. Note that it will take at least 2 minutes for the underclocked constructor to fully back up to the splitter, so don't be surprised if the power graph isn't straight right from the get-go. Now we're going to go to the other side, and in line with a single wall conveyor, we're going to place 2 splitters with the separation in line with the junction of the 2 middle foundations. Use a Mark III lift to bring the 150 pipes into the splitter, and then use a Mark II to connect the splitters together. Then put up the walls as shown. Use a Mark I conveyor to connect the splitter to the double wall conveyor, and then use 3 Mark Is to connect it to the triple wall conveyor. Now that we've finished the steel side build, let's start building the copper constructors. But before we start, there's a change we need to make to the copper tower. We need to remove this lift connecting the 3rd and 2nd floor. To do that, we do the same thing we did for the iron tower in the beginning of the video. So go to the 3rd floor and remove the mergers and belts. Replace the merger and let the output move to the right. Then place another merger going out and remove this window. Reconnect the lift from the 4th floor to the merger. Place a single wall conveyor and connect. We're going to use a lift from this to connect to the 2nd floor, so remove the windows and place another merger in here. Now we can remove this lift and place windows. Place a splitter in line with the second socket, then place a merger with the output down right below it. Then connect the splitter 2 times to the merger. The third belt is connected to the second socket on the other side. Then place another splitter below the merger with 2 other splitters to its sides. Now we're going to come to the back of the wire tower or on top of the copper ingots tower. Build the walls as shown. Then we're going to move to the iron tower and take the 60 steel pipes per minute line and bring it up with a lift. After that, we're going to place a splitter on the second socket of the first double conveyor wall and then another on the first socket of the last double conveyor wall. Connect the belt from the lift to the first splitter. Now remember how we separated the outputs of the wires into two? The 180 comes below and the 240 is on top. Take the 180 using a lift and put it into the second splitter. Use Mark II conveyor belts for the splitter on the left and Mark I for the one on the right. Since we bought the steel pipes into this mix as well, we need to be extra careful with the load balancing and don't accidentally merge both of them together. So for the next load balance, it's going to be a bit difficult to understand, so I'll add the maths in as we move ahead so you can understand. I'm going to color code the numbers, so black is going to be steel pipes and orange is going to be wires. Come to the middle double conveyor wall, and for the socket on the left, use a lift of Mark 1 and then use a Mark 2 lift on the other socket. Now place a splitter in line with the Mark II socket and place another one on top of the first with the input towards the right. Then connect the Mark II to the splitter on the bottom and then a Mark I to the one on top. Place 2 rows of windows and then a row of double wall conveyors. Take a lift and align it with the bottom splitter and then bring it up to the double wall conveyor. Place 2 double wall conveyors, one on top of the other in the middle. Then take a lift and go to the other side and then place it simply like this. This is going to be a temporary lift. And then from the bottom side, bring the lift and keep it aligned with the bottom splitter. This was done so that we can get the lift with the input side on the bottom. Now we can remove the temporary lift. Now we're going to take another belt from the same bottom splitter and then keeping it aligned with the socket like this, we're going to keep it right on the junction. Then we can place double wall conveyor like that. Then take a lift and bring it up and align it with the socket. Now we can just connect it up. Now for the top splitter, we're going to take a belt from this point and then bring it around and keep it aligned with the socket over here. And then turn it 90 degrees, bring it 2 steps ahead. And then what we're going to do is we're going to bring the post 1 step up. And we can remove the post from below and then do the same thing, connect it and bring it to the junction and bring it 1 step up again. Remove that and then now we can place the lift and align it with the socket above. Now we're going to take another lift from the opposite side and then bring it up and keep it aligned with this lift over here and then turn it to the right. Now we're going to build another temporary double wall conveyor there and then keep a lift on the opposite side again to bring the bottom lift as an input. So once we put that on, we're going to connect a lift to this and now we can have the input on the bottom. So we're going to take it to all the way to the bottom and then bring it 2 steps up. And then we're going to connect this side of the splitter to that. And then we can remove the temporary setup here. Now that we've used 1/2 of the steel and wires, it's time to use the other half. Here you're going to take a splitter and place it at the bottom over here, right underneath the second socket, and then place 3 more on top, with the 4th one being aligned with the socket. Keep the input facing away from the socket. Now remove everything else and then do the same thing on the opposite side for the second socket. Make sure that the input is facing away from the socket. Now what you're going to do is you're going to take a lift and then place it like this. Now connect that with the lift from the outside, and you're going to do this with the opposite side as well. Remember to use a Mark II lift here. So what we're doing here is we're splitting the other half of the steel and wires by 3. we need to bring the 240 wires to the other building. So we're going to take it from here, send it to this socket over there. And then I'm just going to connect this because I forgot to connect it before. Now we're going to take the double wall conveyors and then fill this entire side with that. And then the rest, we're just going to use single windows. Now connect it with the sockets as I'm doing here. Now that that's done, cover the entire thing with foundations. Now we're going to take the double wall conveyor and then fill this entire side with it. Use lifts and connect that with the new floor. Now we're going to keep the assemblers aligned with that, and then we're going to connect that up with belts. Now place mergers with the output facing up. Now we're going to place some windows and double wall conveyors, so just follow along.